Let's create a script that will automatically solve a Sudoku puzzle and implement the solution using Python. First off, I'll assume you already knew the basic syntax of Python. Stuff like variables, functions, return statements, dictionaries, for loops, list comprehension, and you get the gist. I'll be using a few different modules too, like PyAutoGui, OpenCV, and NumPy. They don't require the biggest learning curve to understand, but it's always good to know about the possibilities. If you have a look at the GitHub page I've put down in the description here, and navigate to celllocations.py within the modules folder, you'll see the two values at the top here that correspond to daily challenge and standard. What you'll need to do once you've downloaded this page is go to this exact pixel on the chart and note down the coordinates. You can use Microsoft Paint for this, but I use a software called Greenchart. These values are different for both standard and daily challenge, so make sure you check them both. I've already got a completed project here, which for full disclosure I will use for my own notes, but you'll find it on GitHub anyway for your viewing pleasure. Firstly, I'm going to create a new project and call it Sudoku New rather than Sudoku Bot, which is what I had this one saved as. I'm going to go with my previous setup, which used Python 3.1 with a bunch of modules already installed. First thing I want to do is right-click the projects folder and create a new Python package. I'll call it modules because I don't know what else to call it. In case you don't already know, that init file doesn't have anything in it. So if you're not using PyCharm, just make sure there's a file in there called init. So I'm going to create solve.py, detect number.py, celllocations.py, and finally the clicker.py to handle the clicking afterwards. So I mentioned before that I will be including an images folder. This folder has all the screenshots we need to be able to scan the board and replicate it in memory. I'll include a link in the description where you can download this, but for now I'm going to copy and paste the folder from the completed project. If you right-click the project folder, this is where you'll be able to open up the directory. So first off, we're going to import the math module. There are two modes as such on the Sudoku website. We've got our daily challenge, we do once a day, and our standard game, which lets you play any difficulty at any time. Both of which have different heights from the far top left corner of the Sudoku board, and that's why we've set two different sets of coordinates here. If we want to change the mode of this bar, we simply change this top left corner here. I don't recommend you write this code out manually, so if you go to the link provided in the description, you'll find this block of code to copy and paste. Essentially, these are offsets from the coordinates we defined at the top of the page. This is to ensure that you can use this on multiple browsers and you can easily toggle whether we're playing standard versus daily challenge. The only thing we need to make sure is that there are roughly 53 to 55 pixels height and width between each cell. After this, we have a loop that will iterate through all the entries and apply the offset depending on what we've already chosen. Now, the way we access directories in Python as opposed to writing a list is that we put the key and value after the for, and then we put an items property at the end there. I'll do the same thing here with before, and you can just copy and paste its dictionary. I tried programming this so that you can just type the answers into each box, but when I tried this with PyAutoGui, it just didn't want to cooperate, so this way we're doing it with the mouse instead. For context for this function, in memory we'll represent our Sudoku as a 9x9 2D array. So this function will iterate through each cell and return the exact coordinates so we can eventually populate the board. It'll be useful to have as a non-value as well. Right, so as you've probably guessed, this is the start of a function to calculate the validity of a given move. For this, we'll need to be able to crunch the numbers from the board, each cell's value, and the coordinates. Firstly, we'll check if there are any duplicates in the same row. Next, we'll use list comprehension to check if there's any duplicates in the column. Because of the way TV lists work without a module like NumPy, there technically has to be another loop to check the same value on every row, which is why we're using list comprehension in this bit. There are a lot of lines here, but essentially this checks if there's another duplicate in the same 3x3 region. The line that says box start row and box start col is essentially breaking down the Sudoku board into the 3x3 region our value is in. I'll try and make some b-roll to demonstrate this, but for example, if we were at, in brackets, 6, 4, the first number of that region would be 6, 3, and the next few lines of code would iterate through these cells to check if there's a duplicate. Now we're going to put all together to solve the board. So firstly, we're using the function that searches for an empty cell. On the website there's just a blank space, but for our purposes we're defining it as a 0. Then in the grand scheme of things, we're seeing if there's no empty cells on the board, then that must mean the board is solved. Boom, we said true. Let's move on with our lives. Otherwise, we'll move on and transfer the value in the cell we found and use that in the following lines of code. We've got all the information we need to actually use the valid move function. So now we're using a for loop and a conditional to recursively grind out the board. In other words, each cell in Sudoku has a number of potential values, but only one will be correct. If you didn't narrow down each value before writing it down, or typing it out in our case, you will eventually come to a situation where every number has a duplicate. And you would need to work backwards to see where you went wrong. This is what our algorithm is doing. It will keep going backwards to see where it went wrong. So that's how we can solve the Sudoku puzzle, but of course we need a way to extract those numbers from the Sudoku website in the first place, and for that we'll use template matching through OpenCV. So make sure you've got those modules installed, and then import our other files through the modules folder for when we need them. So first of all we're going to use NumPy to create a blank 9x9 grid of zeros. I did try doing this without having to create it first, but I don't think it likes when you try and populate a board that's already been defined, in which respect that makes sense. Why did I even put that in the script, and why am I still saying it? We're not directly referring to our images directory yet, but this will be the general function used to match all the images from our folder to a screenshot our program will take of this website. In our case, we'll only need to give a shit about maxval, so putting an underscore on the rest just makes it look more organised and can remind us we don't need the rest. We'll reference the directory before we do anything. We all know why variables exist, let's move on. I did contemplate creating a GUI on this project, but I figured that would be redundant if we can just Alt-Tab into the game window and wait a bit. And here we will use PyAutoGui and OpenCV to take and process a screenshot. Why do we do it for every iteration, you ask? Well, for one, it makes it easier to reference and crop using the X and Y coordinates of each entry. The screenshot has been processed by OpenCV, therefore we can crop it using these square brackets and semicolons. And now we're using the OS module. As you might have already guessed, this is how you access a file and folder via PNG. Well, in this case, we could also use JPEG. That's only because when I was prototyping this, I was using JPEGs which didn't work, because JPEG never go full JPEG. So because we're in a loop here, all the code we add to this block will apply to every single file in the folder, but just to make it easier to visualize for the time being, I just imagine it only happening to one file. So anyway, we process the image with OpenCV and make use of that template matching function we created previously. Let's say this loop is currently looking at one of the images of number 1. We're going to check if that image appears in the current cell, which we're currently calling cropped region. After that, we have to set a threshold. I found that 0.85 works best. If I haven't already made this disclaimer, the image recognition won't work perfectly 100% of the time, but it will work most of the time. The number variable will be used later, but a little bit of code will extract the integer from the file name. So match value is the name given to the template match, and this will give us a number that has to be higher than our threshold, which is 0.85. The print statements here are just for debugging purposes and you don't strictly need them, but if you need a bit of confidence that the image recognition is working as intended, this will print off all the information you might need to see. In the dictionaries I created for cell locations, I use an underscore in every key in an attempt to be organised. For example, 6_4. 6 being the row, 4 being the column. These lines are basically removing the underscore and deciding whether or not to insert the matched number from the image to, for example, row 6, column 4. So far we have a program that takes a screenshot of the Sudoku board and solves it. What we need to do now is write the function that will plug in the solution. So let's get started. We're going to import PyAutoGui and time because that's all we need besides the dictionaries. We've got our for loops that will go through the numbers, and remember when I mentioned my naming convention for the main dictionary? Well, this function uses formatted strings with the iterators, so just ignore the underscore. We're using time.sleep for 0.1 seconds just because the system can struggle to register information if you don't set it. Now we can go into main.py and mash it all together. We'll just import everything from the files we've worked on already, give ourselves some debugging just in case, and we're all sorted. And that's fab. We can go ahead and go to File, Save All, and make sure you've got main selected at the top here, so we can test it out. I like to make sure my game was the last window active so I can easily alt and tab into it. I hope you liked this tutorial. This was a bit of an experiment for me. So if you liked what I have to say, make sure you do give this a like and subscribe. Or if you have any suggestions on either this tutorial or how you'd improve the code, I'd like to hear it. As for now though, that'll be it from me. I hope you all have a lovely Christmas, and bye for now.